Let's talk about AI. We all know the AI revolution runs on data, but not just any data. It runs on our data. And that right there creates a fundamental clash. You see, to build these incredible AI models, especially for critical things like medicine, they need access to our most sensitive personal information. So the big question is, how do we fuel all this progress without just sacrificing our privacy? Let's break it down.
Seriously, it's a question we all kind of have to ask ourselves. From your private health records to your financial data, the most powerful AI models are often trained on the most sensitive parts of our lives. But what if there was another way? A way to get all the amazing benefits of AI without taking on all that risk?
And this gets us right to the heart of the issue, what researchers have started calling the AI privacy dilemma. It really is a classic battle. You've got the incredible speed of technology on one side and the crucial laws designed to protect us on the other.
To make this super clear, just think about a medical AI that could predict diseases. I mean, that would be amazing, right? But for it to learn how to do that, it needs to see thousands, maybe millions of real electronic health records. The problem is we have these really important privacy laws, like GDPR in Europe and CCPA in California, that basically put up a big stop sign. They place strict limits on using exactly that kind of sensitive data. So you can see the conflict. It's progress versus protection, head to head.
So how do we get out of this jam? Well, the answer might be to get a little creative and, well, make things up. Researchers are exploring this fascinating idea of creating high-quality, fake data that actually preserves our privacy. And it turns out there are two key ingredients you need to make this work. First up, we have synthetic data. The best way to think of this is like a stunt double for real data. It's completely artificial, totally made up, but it's been engineered to have all the same statistical patterns as the original. The absolutely crucial part is that no real person's information is actually in there, not one bit, which means it's safe to use for training AI.
The second ingredient is something called differential privacy. You can think of this as a mathematical shield or a force field for your data. Basically, it works by adding a tiny, carefully measured amount of statistical noise while the data is being generated. This makes it mathematically impossible for anyone to look at the final dataset and reverse engineer it to see if any one specific person's information was used. It's a rock-solid privacy guarantee.
So a recent research paper introduced a framework that brilliantly combines these two ideas. It's called SafeSynthDP. And what it does is it uses the power of large language models, or LLMs, to create synthetic data that also has that differential privacy guarantee baked right in.
So how does this whole thing work? Well, first, you feed a large language model just a handful of real-world examples to teach it the style and the patterns. Then, the LLM just goes to town, generating a brand new, completely synthetic dataset. Now here's the magic trick. As it's creating this data, it's also injecting that carefully controlled statistical noise. You can even adjust how much privacy you want using a parameter called epsilon. Think of it as a privacy dial. The end result is a totally new dataset that is both incredibly useful and private.
Okay, that all sounds fantastic in theory, but does it actually work in practice? I mean, can this fake data really train a useful AI model? The researchers put it to the test to find out. And this is really the million-dollar question, isn't it? If the synthetic data has too much noise, or if it doesn't capture the right patterns, any AI model you train on it is going to be pretty much useless. So what the researchers did was compare the performance of models trained on the original, real data versus models trained on their new synthetic data. And this table shows the results, and it really illustrates the trade-off. For the simpler machine learning models, like a multinomial naive Bayes or a support vector machine, the drop in performance is pretty modest. Take the SVM model. It went from about 87% accuracy on the real data down to 76% on the synthetic data. Now that's a noticeable drop for sure, but the model is still really effective. And here you can see that gap nice and clearly. There is a price you pay for privacy, and in this specific case, it's about a 10-point drop in accuracy. But the key thing is that the model trained on the fake data is still performing way, way better than just guessing. That tells us it really did learn useful patterns.
However, the story changes a bit when you look at the more complex deep learning models. Models like GRUs and LSTMs, which are designed to find really subtle hidden patterns in data, they saw a much bigger hit to their performance. This suggests that the noise we add for privacy can sometimes end up hiding those very complex signals that these advanced models are trying to find.
So, this brings us to our final and maybe most important takeaway. What exactly is the price of privacy, and can we actually control it? It all comes down to this one fundamental trade-off. If you want stronger privacy, you have to add more noise. In the technical terms, that means a low privacy budget, or a low epsilon. But more noise usually means lower model accuracy. On the other hand, if you're willing to have slightly weaker privacy, you can add less noise, use a higher epsilon, and you'll get better accuracy. It's a sliding scale. The data from the research shows this perfectly. Just look at what happens to accuracy as that privacy budget, epsilon, changes. When epsilon is 0.5, which is very strong privacy, accuracy is around 72%. But when you relax that privacy up to an epsilon of 10, the accuracy climbs to over 75%. So you can see it's a clear, quantifiable relationship. And this leads us right to the paper's main conclusion. The authors themselves say that this method offers a viable balance between privacy protection and data utility. That phrase is key, a viable balance. This isn't about getting perfect performance, it's about finding an effective, workable middle ground. So the crucial point here is this. Maybe the choice between powerful AI and our personal privacy is a false one. What techniques like SafeSynthDP are showing us is that we don't have to pick one or the other. We can actually engineer solutions that give us the best of both worlds, a balance where we can keep innovating responsibly without compromising our data. And that leaves us with a pretty fascinating final thought. If we can now create safe, usable synthetic data for super sensitive fields like healthcare and finance, just imagine what other incredible AI-powered tools and discoveries are now within our reach. This could open up a whole new frontier for responsible innovation. Pretty amazing stuff to think about.